OK, let's go back to the bucket array. Remember, I said at the start of the stream that this is all we really wanted to do when we for over a bucket array, right? The actual iterator is a little more complicated, but not that much more complicated. Here it is. And in part, it's more complicated because we're handling taking things by pointer and reversal. But this is the amount of code that it is. Actually, it's got a little bit extra because this is like a feature that we wanted to use in the Sokoban game that doesn't really have to do with actually iterating. So really, without our hard-coded thing, it would be that. But we'll start talking about some of these other features of integrating with for loops. Oh, actually, we'll ignore this, actually, because it's got some features we haven't talked about yet. So we get an array of strings. For each string in this array, we add it to this bucket array, right? And we're just going to show here that it works. So for every item in the loop, so note, first of all, that we're renaming. This is not called it. This is called item. And so part of the protocol of how for interfaces with a macro has to negotiate that name. But so every item is called item. We're going to use a defer to say this should print at the end of each loop. Then we're going to say we're about to say something about x. And then we're going to go 4 times and just say x is whatever, or 3 times. We're just going to print x is 1, x is 2, x is 3 for each item. We're not printing this string at all. Let's print the string. Like we should use the item, otherwise why are we frickin' iterating over the item, right? OK. Maybe that makes this less readable, I don't know. But so we go, there are 69,105 leaves in the pile, right? So we're iterating each of those things. We are about to say something about x. We do it and then print at the end because it's a defer, so it gets popped down there. However, remember at the beginning we said there are some subtleties. For example, if you're going to iterate over this bucket array, you need to start thinking about what the loop controls actually mean. Because if you replace a one-dimensional iteration with a two-dimensional iteration, break and continue need to start doing different things. Because a continue, maybe it's fine if it goes in the inner thing, and a break maybe needs to go to the outer thing, right? Those sort of, the iterator knows what's right. Like your data, it's probably different for every data type, but the for loop needs to let you interface and control with that stuff. Let me just show for right now that that works in a very basic way. So here I've got my, OK, so let's clarify what's happening here, right? This A is our bucket array, which means this for loop is a custom for loop that calls our equivalent of this iterator. This for loop is not a custom for loop. This is just over integers. So down here, we don't want to continue over the integers. We want to continue out of the main loop. So let's first of all show that that works. And if it works, we won't print 2 or 3. Because by continuing out here, we're going to skip 2 and 3 after we do 1, right? So hopefully I'm just not totally lost in the weeds and people get what's going on. But here you go. X is 1, x is 1, x is 1, x is 1, right? OK. So we're just sort of showing macro-driven for loops interacting with non-macro-driven for loops and that sort of thing. Let's show it working with these, right? So first, we're just iterating over the bucket array, just printing out all the things with an index. So we're not doing our inner loop, right? So we're saying there are 69,105 leaves in the pile. We're going to iterate in the reverse direction. We get this handy, very terse syntax that I like using. And when we do this, what happens is Let's go back to our actual thing. What happens is true gets passed in this parameter, right? And then remember, as we opened with, we are able to do this thing very tersely to control the direction over which we iterate the loop. And for this data structure, it happens to be correct that if we want to reverse, then you reverse the outer loop and you reverse the inner loop and you just go, right? And if you want to take things by pointer, similarly, this thing right here. And then this, like I said, that's our own thing that we use in the game. So it's a data-oriented thing. Somebody remind me to explain that at the end, because I don't want to go into it right now, but it has to do with just being data-oriented. OK, so we go forward, we go backward, and we go by pointer to all these elements, right? And so we have a very nice terse syntax for doing all these things. Now there's this name remapping that happens that I've sort of been tangentially referencing here, right? So here we have a two-dimensional for loop. These are both custom for loops that evaluate that macro. So we're evaluating this macro here. That gives us 2 dimensions of loop. And then we're doing it again inside, which gives us another 2 dimensions of loop. So we've actually got a 4-dimensional iteration here. And in this version, we're going to break S2, which should break actually from here. And here we're going to break S1, which should actually break from there of the outer loop and not the inner loop. And so first, let's show that that works, and then let's talk about how it works. So here we're going over every S2, or no, we're going over every S1. Let's talk about what S1 and S2 are. They're just the strings, right? And then I1 and I2 are the indices. And the I1 and S1 are the indices and strings for the outer loop. I should have maybe called them outer. I don't know. So here we're iterating over everything in the outer loop, but we only get to element 0 in the inner loop. And the reason why is because we break from this loop already. This break, named break, is something that we already supported way back for vanilla non-custom loops, but now it actually just works here. So named break here lets us break from this or this. So in this second example, we're breaking out from 0, 0 right here. All right. So you might be saying, oh, well, actually, hold on. Let's talk about why this works. The reason it works is because when we insert code for a loop control, we're able to replace a few things. Like the standard loop control primitives, break, continue, and remove, we can specify what they should be replaced by, right? So we're going to insert something. We're going to say, all right, we're going to insert body, but if we ever see a break, we're going to replace it by break bucket, which breaks us out of this outer loop. That's how the named for loops work, is you say the name of the iterator. And if you say remove, we're going to replace that with this piece of code that just sets the occupied flag by false and reduces the count on the number of elements in the thing, right? And so you can think of this as being like a wildcard search and replace that operates on the piece of code that is inserted when this macro activates, which again is just whatever's in the body of the thing. Now, why does the two-dimensional one work? Because like doesn't this, when you expand the outer one, doesn't this replace the break in the inner one? And the answer is I think the answer is, oh, we only, the identification of this identifier with which loop controls whether the expansion actually applies, right? So when you say break S1, when we're expanding S2, we say, oh, that's actually not a break for our for loop, so it doesn't match for the purposes of that replacement. Same thing here. When we do this, we see this break and we're like, oh, that's a break, but it's not for our